So here we're told that r and t are consecutive integers, and we're given that p is r squared plus t, so this relationship. And we need to compare quantity a, which is minus 1 to the power of p, and minus 1. So I'm actually going to do is to replace p in terms of r and t, because really the information we have is about r and t. P is just an intermediary. Now here I have a plus here, which means I can use the exponent rule and multiply them. Now here, again, it's not very clear to me where it's going, which means that I'm going to use some examples. R and t are consecutive integers. Obvious ones are r is 1, t is 2, so this would be minus 1 to the 1, minus 1 to the 2. This is 1, so that's minus 1. Let's try some other values. If r is, let's say 7, t is 8, 7 square, and then this would be minus 1 to the 49. And I think at this point you probably start to see a pattern. This is odd, so minus 1 to the 49 is minus 1. This is even, so that would be 1. So that's minus 1. Now let's see how we can argue this in a more general way. So if r is odd and t is even, then we can also actually go back to p. Odd square, so p would have this form. Odd square is odd, odd plus even is odd, and minus 1 to the power of an odd integer is always minus 1. Now if you have the other way, meaning p is even square plus odd, things remain the same because even square is even. Even plus odd is again odd. So no matter what the sequence is, meaning if r is 7, t is 8, or 8 and 9, p will always be odd. So this expression will always be equal to minus 1, which means they're both equal. Answer is C.